everyone, my name is Elise North. Today, we're going to be going over the literature search and review process. So we're going to go over why, how, and where to conduct your literature search, and then also how and why to review literature. So for your objectives for this lecture, first we're going to demonstrate a literature search, how to conduct it, what you're looking for. Then we're going to talk about different resources you can find scholarly literature. Some you may have heard of before and some might be new to you. Then we're going to go over the anatomy of a journal article. So this is really going to help you in reading through articles and finding a quick and efficient way to get the information you need. And then we're going to kind of familiarize you with specific journals that will be helpful for you to use for ENS research. And then we'll also go over an organizational strategy that will aid you to help organize your thoughts when you're reviewing literature and think critically about the articles. So step 2 of the scientific method is to gather and review information that relates to one or more aspects of a problem. Oops. Okay, so essentially for this, there's lots of places you can look to find information. There's different types of articles. So for example, there's magazine articles, journal articles, and periodicals. You can look in books, theses, dissertations, there's blog, tweets, news stories, but you have to be careful because some of these are a lot more reliable than others. So as I'm sure you could guess, maybe tweets and blogs are not the most reliable and shouldn't be used when you're reviewing information. You should really go, I would primarily stick to just peer-reviewed journal articles are the best. There's some books that you can find stuff in, but what we're going to focus on today is looking at the peer-reviewed journal articles. So what is the point of conducting a literature search and review? So we're really going to identify gaps in the literature, and we're going to create a problem or question that we want to identify. So for example, we're going over our problem of diet and performance. So there's so many questions we could come up with. What are the difference between a vegan and non-vegan diet? How are animal and plant proteins different? What amino acids stimulate muscle growth? So we really want to kind of do a literature review to narrow this down to what question we really want to answer. These are just some answers to some of these questions. There's different plant proteins, different animal proteins. So we're looking at how they are going to affect your performance. Does plant protein digestibility play a role? Is there limiting amino acids in plant proteins? And a lot of this is stuff that you may not already know. So we're going to read through the literature and we're going to kind of find the answers to our problems and kind of refine our questions so we can really hone in on what we want to look for. So step 1 in gathering literature, first we have to define our question. So the acronym they use is SAM. So it needs to be specific, accurate, and measurable. So you need to make sure your question is asking what you want it to ask, and it has to be something that you're able to measure and it isn't vague, because otherwise you're going to get a ton of different results and you're going to be all over the place. So for example, we have, will a vegan diet limit muscle growth from bodybuilding? We can adjust this so we can make it more specific and more accurate to what we're looking for. So we can change vegan diet to plant protein, and rather than limit, because that might be biased, we can say, will plant protein affect our muscle growth? And then instead of bodybuilding, we can change that to weight training to make it more specific. Okay, and so this is kind of what's going to come up if we just type that question into Google. There's going to be so much stuff, you're going to be overwhelmed. And you're going to think there's all this great information. But one thing to note is a lot of these are not super reliable sources. For example, the first thing that pops up is beachbodyondemand.com. One kind of rule of thumb I like to use is if it's a .com, it probably is not the most reliable source. .orgs are usually reviewed and reliable. So this eatright.org I would click on that. That's probably a pretty good source to start with. Mensjournal.com, again, probably not super reliable, but this is a good way to start to kind of like get your basis, kind of just get you start thinking about the topic. Okay, so this is kind of what's going to come up if you click on these bodybuilding.com. 4 rules for building lean mass on a vegetarian diet. We don't know who's writing this. These are not scientists usually who are writing these. These are journalists. So I would not take that as accurate necessarily. And then as you can see on the right, we have the one that comes from a .org, and it's written by someone who's a registered dietitian and has a master's degree. So that might have a little bit more credibility when you're reading those. Okay, so next what we're gonna go over is how to search for it. So there are certain things called Booleans. Super weird word, but all it really means is you can use and or, and it's gonna help refine your results. So, so we want to connect 2 words like, so we can use or, and it will be replaceable. So if we want to look for soy protein or plant protein, all the results will come up for if it has soy protein or if it has plant protein. It doesn't have to have both. In contrast, you can use and, which will, all the results come up will have to include both words you're connecting. So plant protein and muscle growth. So that will kind of limit, because if you're looking up things that have plant protein or muscle growth, you're going to have so much information. There's no way you're going to be able to like refine that and get what you need out of it. So by connecting it with and, you can limit your search results to including only things that you're interested in. So for example, down here we have a example. So plant protein or soy protein, and we want to look at muscle growth or muscle hypertrophy. So either of those, but it also has to contain either plant protein or soy protein, if that makes sense. Okay. Okay, so then next we have where to gather our literature. So like we went on before, you can start at Google. A better place to start, I would say, would be Google Scholar. Here you're gonna have kind of a mix of sources. There's the only problem with Google Scholar is there's limited full text access. So a lot of times you'll be able to read the abstracts, but not necessarily see the whole article, which is not the best. But it is a good place to start. There's plenty of professors on our campus who are very against Google Scholar, but I usually start there just to get an idea of what I'm looking at. But when you need the whole article, it's not always the best. Okay, so then this is an example of like what types of results will come up when you're looking at one of these search browsers. So for example, here is Google Scholar. So you can use the Booleans in here. So this is how you would do it: plant protein and muscle mass and resistance exercise. So all the results that will come up will contain all 3 of those terms in the article. So that's a really good way to refine your results. You have, for example, here you have 179 results versus beforehand, up here, you're gonna have thousands. So if you just look up one of those or you look up or, there's gonna be way too much. And then this is the same example and how you would put it into PubMed, which is a very popular database for finding articles as well. Okay, so when you're searching databases, there's usually specific ones that you can use based on your field of research. So like PubMed and Google Scholar, you'll be able to find all of them. But then there's some specific ones you want to be aware of. For example, for exercise sciences, in addition to PubMed, you might look at physical therapy and sports med, Sport Discus, Pedro, or Sinahil. And then nutrition and food science, you might look at PubMed, Agricola, or Biosis Preview. Those are just some of the search databases. But yeah, so those are, you should probably be aware of for the test. Yeah, and then you can also, for example, in PubMed, you can filter based on the type of article. So original research would be a clinical study. They have like their own unique data that they came up with, and they're just reporting the data that they found, versus a review is kind of, they did their own literature search and review, and they're just kind of summing it all up. So depending on what you're looking for, you can filter based on that as well. So for example, this would be an example of a controlled trial. First of all, it says controlled trial, it says original research. And then these, they usually will say it's like a randomized controlled trial in the title, which is really, really nice. Reviews will generally say a review of blah, blah, blah. So it's really easy to differentiate those in this field. Okay. So now we're going to go over how to review research articles. So now we know how to find them. We're going to look up how to read through them. Really confusing if you don't know how to read them. So what I would suggest is you're going to go and read through 3 to 5 full articles relevant to your topic. And then you can organize content from each section to kind of organize your thoughts, really. So this is kind of what it's going to look like. The top's going to be your titles, your authors. The first thing that comes up is your abstract. You're going to go into your summary, your introduction, materials and methods. All of these are titled, so they're really easy to follow. So you'll really just have to read through a bunch and get used to it. But then this is kind of how you would organize it. So you read 3 to 5, and then you can kind of put stuff into this table, but just so you don't have to go back and reread the whole article. You can just put down like key points of each one, and then you'll never have to read it again. It's the best thing. I definitely recommend this. So for example, you put the author and the question they're trying to address in the first column, and then you'll do a summary of their measures that they're looking at, the subjects, what they found, clinical applications, and then anything noteworthy about their test. And then you're going to do that for a couple articles just to kind of organize yourself and get a good understanding of what you're reading. So now to go into a little bit more about the different sections of articles, so you can have a little bit more understanding of what you're looking at. So first off is the title. Luckily for science majors, the titles are they're not creative at all. They're going to tell you exactly what you're going to read in the article. So for example, the effects of 8 weeks of whey or rice protein supplementation on body composition and exercise performance. It tells you the timeline, it tells you what they're looking at, they're telling you the measures they're looking at. So all titles will have something like that. So you'll be able to look at the title and pretty much know if it's related to something you're interested in or not. So like I said, it's going to address the research question, tell you what type of article it is, in the study design. So here's another example, the effects of high impact and resistance exercise on calcium and urinary calcium excretion. So you can see the measures is urinary calcium excretion, and the what they did to the participants is high impact and resistance exercise. Another example, effects of physical guidance on short-term learning of walking on a narrow beam. So they're very to the point, you know exactly what these are about. Okay, so next thing right after that is going to go into your author, institutions, and affiliations. They'll usually address any conflicts of interests here. So they'll say where they study, who all was involved in it. They'll say their credentials, if they're a professor, if there's a registered dietitian, etc. Okay, and then the next thing that's going to come is the abstract, which when you think of abstract, just think of summary. I think that's the best way to think about it. It's essentially just the entire article just condensed into 400 to 500 words would be max. Usually they're less than that, honestly. They're still divided into the different, what's it called? Sections. So you'll have a little short couple sentences on the background, couple sentences on methods, your results, and then your conclusion. So you're only going to have relevant information here because you only have so many words. So this is a great place to start. I would never read a full article until I read the abstract and decide this is actually what I want to look at. Because if you read through the abstract and it's kind of not really what you're looking at, throw it away, go find another article. Don't waste your time, because reading the whole article takes a really long time, and it's not an effective way for you to gather information to just read article after article after article if they're not relevant to what you're looking at. Another thing that they will include in the abstracts is keywords at the bottom. So usually there's like 4 or 5 keywords that'll just kind of like ping you to this article. If, for example, you looked up protein quality or whey or rice protein, you're going to come to this article. So that's what those are for. So in here, you'll be able to find the purpose of the study, their conclusions they made, the methods and results that they found. And then a Pico mnemonic was made to help you identify key concepts in articles. So what you're going to look for, the P stands for population or problem. So for our example, our problem is vegans acquiring muscle mass, and then I is intervention. So what's our information? Protein supplements and resistance exercise. And then comparison, we want to compare rice and whey protein. And then our outcome, we want to look at changes in body composition and exercise capacity. So this is just a sample article. You can like breeze through this and see if it's going to address our population of interest, our intervention of interest, our comparisons, and our outcomes. So if your abstract does not address that, again, throw it out, find another article. Okay, so then after your abstract, which is like a little summary, you're going to go into the full article. So you're going to start with the introduction. The introduction is like a background. They do like a little mini lit review. They're going to identify what past research has found, find any gaps in the research, and how their study is going to fill that. They're going to put specific citations from relevant research. So you can go, sometimes I'll just go look up those studies that they cited, because that's a great way to find more articles. Also in your introduction, they're gonna say their purpose of their study, as well as their hypothesis, what they think was gonna happen, and so why they did this study, basically. This is an example of a introduction. You're welcome to read through it when you have time. So after the introduction, you're going to go into the methods. So this is going to be step by step, exactly what they did in their study protocol, like so detailed that anyone else who wanted to do the study could read this and replicate it and get the same results, essentially. So it's long. You probably are not always going to know everything that they're doing. They get really detailed about stats and about specific equipment. So yeah, it's not always super necessary to read through this unless you want to look at what exactly they did. Again, this is going to be subdivided into different measures they're looking at. For example, this one, they subdivided it into phase 1 resistance training protocol. And then there's resistance training protocol, strength, power, body composition, and skeletal muscle hypertrophy testing, supplementation, diet control, etc. And then it's always written in past tense. So what we will do. Okay. And then after methods, we're going to go into results. This is going to be like the exact numbers they got for the results. There's going to be data tables and figures and graphs, and they're usually sectioned off as well. And they're gonna say like if there are statistically significant differences, which I know a lot of you guys don't know how to find that yet, but you will learn. And so you'll be able to look at like their p-values and see if this you'll be able to see the differences between these, if it's significant. There's lots of tables like this that they'll make up, and there will be little like these stars, for example, mean there's a significant difference, which is p less than 0.05. So that's what's going to be found in results. Here's another example of some of the graphs you'll see. Usually they make them pretty easy to follow, but sometimes not so much. So it is be careful to read, like there are little descriptions about this. There's no description here, but you can see like this one is probably a significant difference versus this. I don't see any significant difference that they have seen. And then usually if there's lines like this on bar graphs, this is like the standard deviation. Whereas like the bar would be at the mean. Okay, and then after results comes your discussion. So it's gonna, again, highlight relevant research. A lot of time it'll bring back specific articles they came from the introduction. It's kind of talk about the results in a bigger picture. So not like exactly the numbers, but how it applies, why it's important. They're also gonna go over potential limitations to the study. So maybe they had a very small sample size, or they only tested it in young, healthy men, but they really need to test it in women and different age groups. And then at the end, they'll have a concluding statement. So they're gonna kind of bring it big picture, clinical applications, and then also give implications for future research. Okay, and then after that, they'll always have a works cited. So every journal kind of has different formats for your citations and references and stuff, but this will always come at the end. So these are just all of the references that they used for their article. Okay, so here is an example of a way to organize it. The chart like we looked at before. So for example, this one, we look at the author, date, and question. So they're looking at, does rice allow for the same hypertrophic effect as whey isolates? So the treatment measures in this article was 8 weeks of resistance training, bench, and leg press. They gave them 48 grams of rice protein, which had 3.5 grams of leucine, which is the threshold, and versus 48 grams of whey, which had 5.5 grams of leucine post-exercise. They looked at body composition via a DEXA. They looked at RPE, PRS, quad, and bicep strength and power by 1 rep max and max cycle. And the subjects for this study were 24 resistance trained men who had been training for over 12 months. The findings of this study was that rice was similar to whey in body composition changes and muscle size at 4 and 8 weeks. And the sig means there was significantly similar. And then the strength and power were significant at week 8. So the clinical application for this, what they found essentially is the leucine threshold is the key to planning a plant protein only diet. So essentially, as long as your leucine levels are adequate, then the protein is equivalent to its dairy counterparts. So the notes, they needed a control group because they didn't look at training alone without any protein supplementation. And then what's really important that they found is that pea protein has similar levels of leucine as brown rice. So you could deduct from this that pea protein would get similar results. So from that, we can keep going on. So the next one looked at, is pea protein similar to whey in protein synthesis? And I won't go through all this, but essentially they found muscle size increases across time are similar in whey and pea protein. Again, because of the leucine threshold. So the noteworthy of this is hemp has higher leucine than pea. So then the next article we would look at is what is the protein digestibility of hemp? So we can look we looked at the net protein efficiency, and they found that whole hemp seed meal had the most leucine, and de-hulled hemp seed had highest digestibility scores. So from the application for that, seeds must be whole or in a meal. And then so noteworthy from that, chickpeas have high digestibility scores. And then a question is what the leucine content of chickpeas? So you can see each article can kind of lead you to a next one and kind of just help expand your search. So, I mean, from what we've looked at throughout our lecture, we've seen that pea protein matches whey. This essentially animal protein, as long as we meet the leucine threshold, is the same in muscle growth and strength training than whey protein. So this is an article that talks about that. This was in a magazine. Okay. So then we go into why we do a literature search review, because I'm sure you guys are bored by now, and this is a really long and kind of grueling process, but it's really important in developing your research protocols. So when you're doing your own research study. So for example, I want to do a study, I want to see what else has been done in that field. You don't want to repeat something someone else has done, because that would be a waste of your time. So you really want to do a really thorough search of what has been done and what's missing in the field. So then step 3 would be coming up with your research hypothesis. So for this, we want to look at, for example, we did our literature review, and we want to look at the differences in acute and chronic hypertrophic responses to resistance training between groups supplemented highly digestible, high leucine plants. So we want to come up with a research hypothesis. So what we think, based on the literature we read, is going to happen. So for example, because both plant protein sources are high in leucine, and if isolated and de-hulled are highly digestible, then it will stimulate and sustain muscle protein synthesis equally as effectively. So after that, you would go into your design and methodology, like how we're going to run the test, what we're going to measure, etc. So that's something for another lecture. Don't need to go into that now. But that is all I have for you guys. Feel free to email me if you have any questions. Otherwise, yeah, let me know if any of this was confusing.